Hello everyone, and welcome to the review video for the Q2 exam. Because the the review packet was a little bit longer this time, this video has been broken into two parts. This is part 1. This is problems 1 through 16, and problems 17 through 29 will be in a different video. So let's get right into it. So for number 1, what is the quotient when the following division is performed? Well, it's division, and so what you want to do is divide each term by the divisor and then reduce. So 12 divided by 3 is 4, and remember your rules of exponents is that this is really x to the first, and so you subtract the exponents when they have the same base and you're dividing, and so you'd end up with 4x squared plus 3x, and then 3x divided by 3x. A lot of kids kept telling me this was x in class. No, any number divided by itself is 1. And so we use the same technique over here on this problem. Divide each term by the divisor, and this will give me 3y cubed plus 4y plus 2. All right, next slide. So, perimeter. To find the perimeter of a polygon, a closed figure of straight sides, you add up all the sides. So this is just 5x minus 2 plus 3x plus 2 plus 2x minus 1. And that, if we combine like terms, that gives me 10x minus 1. Number 4 is the same type of problem. This is x plus 7, or sorry, x plus 5 plus x plus 7, and that'll give me 3x plus 12, combining like terms. Once again, I go through these videos kind of quick. You have the opportunity to back up, rewatch, but just to keep the videos from being forever long. All right, so here when we subtract polynomials, you have to distribute the negative. So this is 4x squared minus 6x plus 7 minus 2x squared minus 3x plus 1. All right, the signs of everything inside the parentheses change. Then we just combine like terms. All right, and this one will be exactly the same. 7x squared minus 5x minus 10 minus 3x squared plus 6x minus 11. And so that will give me 4x squared plus x minus 21. All right. So now we have to multiply these out. And so your teacher may have told you FOIL or the Punnett square. I use what's known as double distribute. So you distribute the first, oops, sorry, I just wrote there. Distribute the first part, right, x minus 3, and then I distribute that once, and then we distribute again. So this will be minus 3x squared plus 4x minus 9x minus 12. And then we will combine like terms. Oh, whoops, sorry, there should be plus 9x. And I'll get negative 3x squared plus 13x minus 12. Sorry, it was a negative times a negative is a positive here. All right, and the second one we do the exact same way. 3x minus 2 times x minus 2. That'll give me 3x squared minus 6x minus 2x plus 4, or 3x squared minus 8x plus 4. All right, so I know kids really struggle with their rules of exponents. So I'll try and go through the rules of exponents. Remember, anything raised to the 0 power is 1. So this is 1 over 4x to the negative 2. Then a negative exponent, if you have 1 over x to the negative 2 power, that becomes x squared. But the negative 2 here only applies to the x. So this would be x squared. The 4 remains unchanged. Once again, if we raise a exponent to a power, like x to the 3rd to the 4th power, then we're not multiplying bases, we're raising a power to a power, you multiply the exponents. So up here, this is going to be 9x to the 8th, because we have to square the 3 as well, times 8x cubed all over 3x to the 6th. Now, once we multiply two numbers that have the same base, we add the exponents. So 9 times 8 is 72 x to the 11th over 3 x to the 6th. And lastly, when we divide two numbers that have the same base, we subtract the exponents. And so 72 divided by 3. Actually, you know what? I can't do that one in my head. Give me a calculator. Is 24 x to the 5th. All right, so this is probably the easiest problem on the whole worksheet. There's a lot going on in here, but it doesn't matter because it's all raised to the 0 power, so the answer is 1. Here, for D, we're dividing. So 72 divided by 3 is 24. Excuse the bell. X to the 3rd over x to the 8 is x to the negative 5th, and y to the 7th divided by y to the 7th is y to the 0 power, because we subtract the exponents. Well, anything to the 0 power is 1, so that just goes away. Or you can just remember it as any number divided by itself cancels. Now, I still have a negative exponent here, so this will be 24 x to the 5th. Remember, a negative exponent means you're going to move it from the top to the bottom, or if it's already on the bottom, you're going to move it to the top. All right, so here I'm going to multiply all this out. There's no exponents on the outside here anywhere to worry about. So this is just going to be 2 times 6 times 2 is 24. Then x we add, so negative 5 plus 7 is 2 plus 3, so this will be x to the 5th. Just add up the exponents. All right, so here, this is all raised to the negative 1 power. So I would rewrite this as 48 x to the 9th over 2x to the 4th, which will be 24 x to the 5th. Right. For this one, I'm raising a power to a power, so this will be 9x to the 6th times 2x to the 3rd, and that'll be 18x to the 9th power. Wait, I messed that up. Sorry. This isn't squared, this is to the 3rd power, so this is 27x to the 6th. So this is all 54x to the 9th. My apologies. Once again, raising everything in here to the 3rd power, so that's 8x to the 9th, y to the 3rd. Because when we raise a power to a power, we multiply the exponents, times x to the 6th, y to the 10th. Now I'm multiplying bases, so this will be 8x to the 15th, y to the 13th. All right, so here, squaring the top part, 36x to the 8th, y to the negative 6 over 4x y to the 6. So 36 divided by 4 is 9. 8 minus 1 is 7. And negative 6 minus 6 is negative 12. So my final answer will be 9x to the 7th over y to the 12th. Okay. Find the area and perimeter of the rectangle below. So remember, if you have a rectangle that was, say, 3 by 7, then the area would be 21, and the perimeter would be 3 plus 7 plus 3 plus 7, or 20. Area is the length times the width. Perimeter is add up all the sides. So for the problem they gave us for the area would be 2x plus 5 times x plus 1. And this is just like the expansion problems we were doing a few minutes ago. So this is 2x squared plus 7x plus 5. The perimeter is adding up all the sides, so that's 2x plus 5 plus x plus 1 plus 2x plus 5 plus x plus 1. And that'll be 6x plus 12. All right, so which of the following, what is the polynomial represented by the model? So I have 2x squared, so that's 2x squared. Now, a lot of times with these, it's easy to cancel these out. So if I have a positive and a negative, they cancel each other out. And so this is just going to be 2x squared. Sorry, I messed that up. Sorry, each one of these was an x squared, so that's 2x squared. And then I have 2 x's, so that's 2x squared plus 2x. Sorry, I'm recording this during lunch, so there's a million bells. Same thing here. Those cancel, 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 cancel. And so what I have is an x squared plus 2x and then minus 3. All right, so this is function notation, which we've done fairly recently. And all function notation is saying is, hey, what is f of 2? So f of negative 2 equals 6 times negative 2 squared minus negative 2 plus 10. If you simplify that all the way out, you get 36. Now I'm going to double check my work here, because that's what I had written down, but I can make a mistake, so let's be careful. So this is 6 times 4. Remember, when you square negative 2 times negative 2 is positive 4, plus 2 plus 10. So that's 24 plus 12. Yep, that's 36. All right, f of 4 is then going to be negative 4 squared. Now, one of the key things is, especially if you're using a calculator or even Desmos, is when you sub in for x, put what you're subbing in parentheses. Because this will be negative 16, because you order of operations, you do the square, then multiply by negative 1, plus 8 plus 3. That was at a 7, sorry, plus 28 plus 3, and that gives me 15. For this last one, f of negative 1, that's 5 times negative 1 squared minus 3 plus 1, and so that's just 5 minus 3 plus 1, which is 3. Okay, so for this one, what I would do for this is I would just graph each one of these in Desmos. You have access to the tablets. Why make life harder than it has to be? Bring up Desmos, which is what I'm doing right now, off screen, and waiting for our internet to work at the school patiently. Maybe not so patiently. There we go. And then bringing it over here. Let me see if I can cheat here a little bit. All right, and then let's. All right, and so I'm just going to graph these and look at the number of zeros I have. So y equals x squared, why am I not typing? Y equals x squared minus 6x minus 2. If I look at that graph, remember, zeros, roots, and x-intercepts are all the same thing. So, when I look at this graph, there are two x-intercepts. And rather than graph all of them, let me show you one that's not. So for C, option C, that is x squared minus 6x minus 9. Oh, and I forgot my y equals, which is why it's not graphing properly. Well, y equals, oh, plus 9. Always double check that you type these in correctly. Now, when I look at this one, this third one only has a single 0. It does not, and the question was, which one has exactly 2 zeros? So C is out. If you graph D, it's a line, so it only crosses once. And if you graph E, it has no zeros. So the correct answers were A, B, and F. All right, so let's break down these here. Find the following. So the x-intercepts are -5 and 1. We should write that as a set of values. The y-intercept is -5. And if you're in my classes, I already taught you that when you have y equals ax squared plus bx plus c, c is always the y-intercept. The domain is all real numbers, which can be written fancily as x, all values of x, such that x is a member of the set of all real numbers. But the range is going to be determined by the vertex. And we can see right here the vertex is at -2, -9. And because this is a parabola up, it goes up forever, but there aren't going to be any points below -9. So the range is going to be all values of y such that y is greater than or equal to -9. And then for these last points, there's two ways you could do this. You could plug -1 into the function they gave you for x and find out what you get for y, but you can also just get it right off the graph. Right? -1 is -8. -4 is -5. And 1 is 0. All right, for this one, the x-intercepts are -1 and 3. Right here and right here. The y-intercept is 3. The domain is all real numbers. The range, now this is parabola down. So once again, look at our vertex. Our vertex is 1, 4. So 4 is the maximum value. There'll never be any values higher than that. So the range is all values of y such that y is less than or equal to 4. And it's the less than or equal to is important. And then for f of 1, I get 4. F of -2, I get -5. and f of 2, I get 3. All right, and so this is the last slide in part 1. There we go. Get it all in one shot. So I have to match the graphs. Now, you could easily use Desmos, type this in as it's written, and just type, for this one, instead of f of x, you just type y, and graph them in Desmos. But that's missing the point of this, which is the idea of the relationship between factors. So if your factor is x minus 4, and zeros. And zeros are the opposite of the factors. So this has a factor of -4 and -6. So the zeros should be +4 and +6. So this is A. For this one will have a factor of +3 and -2. So that's B. This one will have a factor of -4, zeros of -4 and -6. So that's C. And this one will have zeros of -3 and +2. So that's that one. All right, and for 15, oh, I seem to be missing 16. I'll fix that in 1 second. We can pause. If 16 somehow got cut off. So plot the x and y axes, x and y intercepts on the graph. So those are the x-intercepts. And that's the y-intercept. All right, how many zeros are there on the graph? 2. Give the coordinates of each intercept. So the x-intercepts are -3, 0, and -1, 0. And the y-intercept is 0, 5. So the zeros of the equation are -3 and -1. And the zeros are the x values of the x-intercepts. All right. So give me 1 second to, I'm missing a slide maybe, I think. Yes. So we will pause momentarily. All right. So here is number 16. Plot the x and y intercepts. So there are my x-intercepts. There's my y-intercept. Once again, if you've been paying attention, so how many zeros are there? 2. The x-intercepts are -2, 0, and 4, 0. The zeros, and then the y-intercept is 0, 8. I don't think, this is not the equation of that graph, but we'll deal with that later. The zeros, therefore, are -2 and 4. And once again, the values are the x values of the x-intercepts, are the zeros. All right, so that's part 1. Part 2 is the rest of the video. Good luck on your test.